गुड इवनिंग फ्रेंड्स, स्टडी विद अपाल इंजीनियरिंग एंड जर्नल जियोलॉजी परवीन सिंह बुक। तो हम चैप्टर 10 पढ़ रहे हैं जो कि द स्टडी ऑफ मिनरल्स है। एक्साइल रेशियो, इट इज़ द न्यूमेरिकल्स एक्सप्रेशंस फॉर द relations ratio existing between the length of different crystallographic axes in a given crystals and is always a constant for that crystal. When all the three crystallographic axes have the same length as in the crystals of isometric system, axial ratio need not the determined whence however the length of one and more axes are unequal. Then this ratios become of a greater significance and has to be determined. In such cases, the length of one of the three or four axes is taken as a unity, and those of remaining axes is expressed in relation to that axis as a V cell. See later on. There are well established conventions for selecting the axis for fixing the unit length in different crystal system. Example, in a crystal that can be referred to three crystallographic axes of which two horizontal axes A1 A2 are equal and interchangeables, and the vertical axis is either longer or shorter. The axial ratio is in figure A2 ratio A2, and A ratio C is equal to A ratio C, and since A1 is equal to A2. Parameters, indices and symbols. This is most important figure, so please try make it. It has been already mentioned that exact mathematical relations exist between various phases of crystals. In actual practice, these mutual relations of the phases are numeric determined. Yes, determined and expressed with reference to three. In here determined ही है जो कि misprint हो गया. Reference to three in one case and four crystallographic axes. The numerical expression for such a relationship of a given crystal phase with the crystallographic axis is variously termed as a parameters index. Plain indices or symbols each term having its own significance and parameter. The relative intercept made by a crystal's face of on the three or four crystallographic axes are known as its parameter. For instance, in figure, the three crystallographic axes are represented by x o x, y o y, and z o z with their relative length, and the OX is equal to A, OY is equal to B, and OZ is equal to C. Let us consider a face represented by a plane I, J, K's and occurring on this crystals. The intercept of this planes and face with the three axes are O, I, O, Z, J, and O, K, which expressed in terms of the length of the axes are L first A, first 1/3 B, and 1/2 C, half. So therefore, 1A and 1/3 B and half C are parameters of the face, and these are generally expressed as parametrical ratios, and the 1A ratios, 1/3 B ratio, and half C. So one can draw a number of other planes with reference to the above three axes and determines their relationship in the same manner. Indices, in common practice, the relationship of a crystal's face with the crystallographic axis is expressed in simple whole numbers, and which are called indices. These indices are however always based on and derived from the parameter. There are number of methods for deriving indices from parameters, such as the Newman systems, the Goldsmith and system, the Weiss system, and the Miller systems. Of these, the Miller system has been extensively used in the descriptive crystallographies and is followed in this book also. In the Miller systems, the indices for a given crystal face and derived from its parameters into the simple steps. By taking the reciprocals of the parameters actually obtained for the given phase, and by clearing the fractions if n is by simplification and omitting the letters of for the x's in the final expressions. Expression example, let us take a case for 4 faces with the following parameters. 1 1a ratio 1b is ratio 2b, and second half a ratio lambda infinite b ratio 1c, half a ratio 1 thirds b ratio 1c, and 1a ratio infinite b ratio infinite c. Reciprocals for these parameters are respectively 1 by 1a